what is it that shows if somebody's doing this in a pilot program? Because everybody keeps going back to, cylinder brakes, but how do you feel really good inside that the data you're getting is decision grade data?
So from our experience, in generally, we want to do two things, right? And number one, it's, the lab controlled cylinder testing. So the cylinder has been very inconsistent. It's basically depends on who made it, right? How you
Mhm.
make it, how you cure it, how you transfer it. But if there is one ACI certificated technician who make the cylinder meticulously, right, cured as what they instructed, and tested as ACI, or ASTM C39 standard, and then you typically get consistent results, right? So that's what industry looking for compared to the cylinder testing. Some
Mhm.
states they do a core drill, right? So for example, Indiana does core drill testing, and then looking at the real in place strengths that can compare to our data, and then very comparable as well, right? So we are roughly about 10% within that pretty tight band region, right? Again, concrete is composites material. You cannot expecting this cylinder exactly the same as next, right? So roughly people looking at it from industry, from ASTM C39 standpoint, is about 15% within three cylinders, right? So we're very much within that range or even tighter, so our data. Joe,
Yeah.
would you
So
like to
a
add
lot.
on? Yeah.
Yeah, I mean, we have probably 10,000 pours that we have done to validate the data against cylinder breaks. And so it's a pretty well established um, database, if you will. And we have data that spans every type of concrete from 500 psi up to 20,000 psi, and it's all about collecting the data and then using today's, I think, AI models that help discern the information to give us something that's really strong. Um, I think analyzing those results is really a key. Getting that done, and then driving consensus after you do that. So you bring up a good point. Does do people believe what they're seeing? The one nice thing about our sensor is that it's like a third party QC device or QA device. You can't fake the data. You can't fake the output. On a thermocouple with a maturity sensor, you could change the temperature theoretically. You could kind of fake that output. You can't change the output in our sensor. It's buried in the concrete. It's going to read what it reads. Also, you can't it's not dependent on how someone puts the sensor down in the ground compared to like cylinder brakes or beam brakes, like you said, Luna. That has human interaction. That has a lot of variability because every individual who makes a cylinder or beam might make it slightly different. How many
Yep.
times they pound it with the rod, uh,
Yeah.
how they convert it, how they carry it, where it's stored until it gels, when it gets brought back to the lab. There's so many variables in there that you start to really question whether or not cylinders and beams are really the accurate way to measure strength. And yet, what do you always say? We've been doing that for over a century. It's an archaic method, probably been doing it since the Roman times, right? To really
Yep.
determine strength. So that's really important. And our process of educating the customers as well is really important to continue to get support from us.